As the part of data mining experiment number 5, I am going to do the data classification based on support vector machine. In machine learning, the support vector machine or support vector networks are supervised learning models with associated learning algorithms that analyze data used for classification and regression analysis. So here I am going to do the support vector analysis using the RapidMiner. So for that I am going to do an analysis in the sample dataset. So the sample dataset I am going to take, and here the sample datasets are being provided by the RapidMiner. I am going to take Sona sample dataset from the RapidMiner. So this is the Sona dataset. So in this dataset, so first we will check what is there inside this dataset. So we can see the dataset and the number of attributes also. There are 60 attributes in this dataset. So we are going to perform the SVM modeling inside this. For this performing this modeling, we need to do that model inside the validation phase. So we are going to do the cross validation inside this data. So this is cross validation. Inside this validation we are having two phases, training and testing phase. In the training phase we need to apply the model, and testing phase we can test this model. So inside the training phase we are going to give the model. Here it is support vector machine. It's already there inside this modeling predictive. This is support vector machine. We are giving the input inside the support vector machine, and the model will be given to a model port and the weight will be given to the port. So the training phase is over. Now for the testing phase we are going to give apply model. So in this apply model we are going to give the model as input and test phase testing also as input, and we will check the performance next. So we have given the performance output also. Now we will go back, and from this validation we will give the model output, training output, and the average as the result. The design phase is over. Inside this SVM model we are having we need to consider about, we are having this much options, and we need to consider the two options in main. This is kernel type and C value are most we need to consider. This kernel type we will check whether the classification should be linear or non-linear. Predefined classification is being done as linear, so that is dot classification, and this radial will be non-linear classification. And other than that we are having polynomial, neural, ANOVA, and Gaussian example. So we have just giving the linear classification. Next is C value. The C value will be checking the generalization. If it is 0, it will be predefined as generalized. If it is given as any other value, we will be giving as a user specified value. If it is being given 0.1, 0.2, 0.3, 1.0, etc., we are giving a user specification for that. Currently I have given 0.0 values, and some other options are also there. Let's check the output for this. We are getting the output for the linear classification in this SVM. In the performance we are having accuracy of 78.86%, precision as 80.70%, recall value as 80.98%, AUC optimistic graph and AUC pessimistic and normal AUC graph is being given. This is the example set, and this is the kernel model. here the classification is based on the attributes, attribute types and weight values. This is being given as the weight values, and the decision is being made by this weight, considering this weight. If the weight is above a specified value, then it will be classified as first class, and below the specific value, attributes will be specified as the second class. Also, the total number of support vectors are taken. It has been 208, and the offset value being taken as 207. Let's now check the radial classification. Now it's linear classification being checked, and just now check the radial classification. So in this radial classification, accuracy has been changed to 53.38%. That's not a good one. It's been more accurate in linear classification than in radial classification. And also kernel model also has changed. The weights has been changed from 0 point to 52 point. It's better we will take dot the linear classification, and we will just give C as 0.1. The accuracy has been reduced now. C value also is having a more precise and more role in this, so we will give as 0.0 only, and we will get the more precision or accurate value than this non-precision. So this is the accuracy, and this is the classification being given. So this is how we will classify data set using a SVM machine. Thank you for watching this video.